Hello. In this video we're going to have a look at how to make a new library for Altium and how to generate a new footprint and schematic for a library component. We're then going to show how we would integrate it with the circuit that we built in the first tutorial. So we're going to start by clicking on our project over on the left hand side, right clicking, choosing Add New to Project and then a schematic library. We can actually make the PCB library first if we want. It doesn't matter which order you create these documents in. So let's start with the PCB library instead. The PCB library generation window looks very similar to the window we used to design the circuit boards. Last week we had a look at designing this circuit here, and you can see it's a very similar layout. The first thing that we're going to do is have a look over here on the left hand side. We can see there is a new PCB component which has been manufactured for us. We can double click this if we want and rename it. So why don't we call it 555 timer, and this is going to be a DIP package, dual inline package. What that means is that our component has legs like this and it's a dual inline, so 2 lines. Description 555 DIP will probably do. I might remove this up here as well. 555 DIP for both the name and description. We can ignore the height property for the moment, but so the first thing you'll notice is we have an origin on the center of the screen. As I move my mouse around, you will see that we have an X and a Y in the top left hand corner of the screen up here. And as I go to here we have 0, 0. The dx and dy values also change. This is going to be a moving number, so if I hover over this 0, 0 point and press the insert key, you'll see it resets the dx and dy. This is good because we want it to be something that moves around as we move the mouse, starting at the origin point. So the first thing I'm going to do is save this library, because we haven't saved it yet. I've got one here already, PCBlib1. Let's call this 555 lib. Save. So the first thing we're going to need to do is add a pad. We can do that either by clicking the pad button up here, by right clicking and choosing place pad, or by simply using the key command pp. This adds a pad to the mouse. Before we click anywhere, we're going to want to press the Tab key to open up this window. We'll remember whenever we're doing anything in Altium, before we click and place, we can press the Tab to access the properties. This is going to be a multi-layer pad. That means it will have a pad on the top, a hole through to the bottom layer, and then a pad on the bottom layer as well. The default sizes and shapes are probably going to be fine for us because these are default for most pads. There will be no problems here. What we do need to change is the designator. When we look at our document, we can see that we have pins 1, 2, 3, 4, 5, 6, 7 and 8 working in a kind of anti-clockwise motion around this pin. So the first pin is 1. We're going to need to make sure that our designator is set to 1. This will make sure that is the first pin. So designator 1, we can press OK. And you'll see it's now attached to the mouse. Remember, if I try and move around, it will scroll the page in the direction I'm moving. Kind of helpful, but we want to make sure we're locating straight onto this pin. So what I'm going to do is I'm going to click, move my mouse away. You'll see there is another pad attached. Now, what I could do at this point is continue to move my mouse along and wait until I get to the right position, which would be 100mm, and then click again, and then move my mouse along again, and click again, but we run the risk of there being an error or things being slightly out of line, so this isn't the best way to do this. I'm going to hit escape and I'm going to delete this last pad that I placed, making sure I've only got one pad here. Now the order that we do these next steps is quite important. What we're going to try and do is make an array of pins 1, 2, 3 and 4 automatically. So we need to know the distance between these pins. We can look up in our datasheet and see that the distance is this constant e here. By comparing that in our table, the small e, we can see that in inches this is 0.100. That means 100 mil. Not 100 millimeters, 100 mil. It's an imperial measurement. I can click this pad, choose right click, copy, and then set the origin. So we click again in the center of this pad. Very important we do that now. We can then delete the pad. I know it seems strange to delete something we've just copied, but bear with me. We can then edit, paste special, uncheck paste on current layer if it is checked, paste array, and we're going to say we want to paste 4 pins with an increment of 1, so 1, 2, 3 and 4, and we want our spacing to be 100 mil in a linear fashion. We don't want any Y spacing because we just want a horizontal array. And press OK, and I'm going to click back on this origin point. Ta-da! 4 pins. Very useful. We can continue on in the same vein to add the next pin. So what we're going to do is we're going to click on the pin 4, right click and copy. Click on the origin of pin 4, but this time we're not going to delete pin 4 because we want it to remain where it is. We're going to edit, paste special, make sure this is unchecked, paste array, item count 4 incrementing at 1, it'll start automatically on 5 because the pin we have highlighted is 4, but this time we want a minus 100 mil spacing. Now the question is, why do we want minus 100? Because we can see that we've got 1 through 4 on the bottom, but 5 through 8 go in the opposite direction. So we don't want to continue 5, 6, 7, 8 in this direction. We want to do 5, 6, 7, 8 left. We also need to check the distance here between 4 and 5. How far should these pins be away from each other? So there are a couple of different things we can check here. Let's look at the constant f to begin with. So f is showing 260, which would be the width of this package. That looks about right. We could also look at the constant e, which is going to show a minimum of 0.313 and a maximum of 0.384. We can also look at E4, which is the width at the top. This is going to show 0.3. Because this is showing a minimum of 0.3 and a maximum of 0.384, we should probably choose something in the middle. I would suggest something like 0.35, so 350. We'll head back into Altium, click OK, and we need to make sure we can see that our origin is set to 0, 0. The dx and dy in the top right-hand corner, left-hand corner, is set to 0, 0. So we're going to need to make sure that we go up by 350. There we go, 350. I'm going to click once, and we can see the pads have been added automatically. Now it seems there's been a slight error here because pins 4, 5, 6 and 7 have been named 4, 5, 6 and 7 respectively. This is a bit of a shame, but nothing that we can't fix. So I'm going to right click and escape, double click on this pin and simply change the name. 5, 6, 7 and 8. There we go, problem solved. The last thing we're going to do is add a little bit of a drawing. So I'm going to choose the top overlay, the line tool, and I'm simply going to draw a rectangle roughly the size of my IC. And I'm going to add a little marker in this corner to indicate that this is the position. Oops. Of pin 1. And there we have it. My footprint has been finished. Oh, I must right click to cancel the current command and then I can save, Control S, and now I have my device saved. So we've made a footprint. Now we need to go and we need to try and make a schematic. So I'm going to head back to my projects view. right click on my project, add new to project, schematic library. And here we have it. There is a component added already. We're going to double click this and we're going to call it IC question mark. You'll recall as we add ICs or we add chips to the board, it adds this kind of resistor question mark or IC question mark. We can call it U question mark is sometimes done, but IC makes sense to me. And the description I'm going to give to this is a 505 timer IC. Everything else can be left as default, but we want to add a model. So we can choose add, footprint, browse, and we'll see that the footprint we've already made is showing up here as one available to use. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to choose OK, press OK, and this has been added. I can press OK a final time, and we see the device is added down here. What we're going to do next is start to draw our schematic. So we're going to start off with a rectangle, always a good place to start. Might help if you zoom out a little bit at this point so you can see the whole thing that you're adding. And I'm going to add a square. There we go. So we've now added this square, which is going to be the schematic view of this IC. And we need to add our pins. Now the pins don't necessarily need to be added in the same positions that we have on the IC here. You'll see we've got 1, 2, 3, 4, 5, 6, 7, 8 on the IC, but it might make sense to lay them out differently on our schematic view. If we refer back to the datasheet, and I've scrolled up here automatically, we can see we've got the numbers here, GND, trigger, output, reset, control, threshold, discharge, and VCC. It might make sense for our ground pin to be on the bottom of our schematic and our VCC to be on the top of our schematic, with various things laid out. If we look through this datasheet, we can see that they have actually provided us with a recommended layout for a schematic view. It's over here. So we have ground at the bottom, VCC at the top, and the other pins are scattered accordingly, but you can see that they're not in order. 1, 3, 5, 6, 7, 8, 4 and 2. If I load this on one side of my screen so that I can refer back to it later, and I load the schematic view on the other side of the screen, then I can start to lay things out. I'm going to click up here and choose place pin, or if I want I can right click and choose place pin. The first pin that shows up will be whatever the last pin you made was in Altium, so for me it's showing as a VCC pin. Before I click this anywhere, I'm going to press tab and I'm going to start to reset this. So the first pin I want is going to be a designator of pin 1. It's going to be my ground. I'm going to give it a display name of GND. Now you can see here it's showing with the name inside and the number outside. This is very important. The number goes outside and the name goes inside. Everything else is fine and can be left as it is, so I'm going to press OK. And then I'm going to add it to the bottom of this board. But you can see it's the wrong way round. Here we have the name outside and the number inside. I'm going to press space to rotate my component. And you can see at the bottom of the one there's this little X at the bottom of this line. That's the place where you're going to be doing connections to. So I'm going to place this right at the bottom, like that. It's automatically going to add a second pin for me. But a second pin for me is not going to be called ground, so I'm going to press tab. I'm going to rename it trig for trigger. I'm going to press OK and rotate. And then I'm going to place it as recommended on this side of the PCB, this side of the schematic. And I'm just going to keep doing this. So tab, next pin is output, pin 3, OK, place that over here. The next pin is 4. I know that this is the reset pin. Okay, so press space. And let's have this near the top. Pin 5 is going to be my control pin, and that's going to be over here. Then we have pin 6. Now pin 6 doesn't appear to have a name on this schematic here. So if I just scroll back up to the top, it'll tell me what it is. Okay, so 6 is the threshold, 7 is discharge. Scroll back down again. So 6 is thresh. Oh, this is the wrong diagram. Where is the one I was using previously? That was it. There we go. Place pin. 6 was going to be thresh. 7 discharge. And last but not least, VCC, which can go up to the top. And just like that, I have the schematic finished. Exactly the same layout as in the datasheet, so it's nice and consistent for anyone who wants to check it up later. So we can save this. I'll save it as 555 lib, but the schematic version. Save, and we're done. So if I maximise this again and head back to my original schematic, the only thing left to do is go to libraries. I can choose my library from the list. Libraries, project, 555 lib, add library, oops, cancel. It should be here already, there we go, 555 lib. And here is the component with the footprint. So I can drag it out, place it. The only thing left to do would be to wire up our pins. So we have our VCC and ground. Let's wire those up as an example. So I can take my ground, place it at the bottom. I can take a 5 volt line, place it at the top, and then I can wire the pins on. So that's a very basic introduction to how we would go about creating a schematic library and footprint. I hope it's been useful, and useful as a recap.